Hello students, welcome back. In the first video, we went up to the definition of the derivative. And in the second video, we talked about the derivative function and some further behavior. For the time being, we don't have to worry about the derivative function, and let's do some problems regarding the derivative. But you have to recall the derivative is instantaneous rate of change, which can be represented as the slope of the tangent line, as you can see in this kind of static view or this dynamic view. Secant line converging into the tangent line. Anyway, that was the derivative, graphically speaking. And excuse me, let me get this expression, close that hand, and let's do some problems associated to that. Alright, here's a graph and answer these questions. Find all x-coordinate values at which f prime of x, the derivative does not exist. Okay, alright. We have 2 points that are standing out, x equal to -4 and x equal to 0. We have breaking points there. There's no chance we're going to have any kind of derivative. We have discontinuity. And then we have one more. Right here, down here at x equal to 3, we have the cusp point. At cusp point, the derivative does not exist because left-hand side, we're looking at this slope of this line segment. To the right hand side, we are looking at this slope. Tangent line is horizontal. We have two different slopes, so the slope does not exist. So x equal to -4, x equal to 0, x equal to 3, and because of these reasons. Now, how about the second problem? Precise value of the derivative f prime of 1 at x equals to 1 right here, and we're looking at the slope here. We need slope of tangent line, but we don't need tangent line. We have line segment here. So line segment here, this one is itself a tangent line. All you need is the slope of this line segment. What is it? You count, -4/3, rise over 1. By the way, this is not just f prime 1, but f prime of 2, f prime of 1.5, f prime of 2.6, f prime of 0.3, they all share the same slope because we have the same line segment there. Next, f prime of -2. So we are talking about this point here and what is the precise derivative or precise slope of the tangent line. It's curved. It's not a line segment. Can we still find it precisely? Yes, we can. That's because this is a local minimum. At local minimum or local maximum where the tangent line is horizontal, you can see this is local minimum, excuse me, and tangent line is horizontal. I'm running my mouse around that horizontal line. So horizontal line has slope 0. It's that simple. Finally, estimate the derivative at f prime of 4 right here, and this time you cannot find out the precise value. So you'll have to pick up a ruler and then draw a tangent line and then estimate it. I think that's the best way to do it. I can clearly see that this has to be positive because tangent line is certainly going up. Otherwise, everything is approximation, so I'll take full credit with any kind of reasonable answer. My estimation is about 1.5. What is yours? Okay, how about these graph problems? These are a little bit harder. Same graph, it's the same graph, but the problems are written in a bit more complicated fashion. Instead of giving you prime notation, I gave you the limit notation, and this is the average rate of change, rise over run, with the limit. So this is a derivative evaluated x equal to 2 right here, and that slope is, well, it's inside this line segment, so all you need to do is to find out the slope of this line segment. It's negative 4/3. Getting this line segment, that's not too bad. Understanding this expression is the hard part. It's a slope. Whether it is written in terms of average rate of change with the limit or Newton quotient with the limit, it's a slope. How about the next one? It's Newton quotient, so it's a slope, but where? X equals to negative 2. Right here we have horizontal tangent, so this limit is 0. You can write it as Newton quotient, or that's average rate of change formula with the limit. Either way, we're talking about the slope of tangent line, the derivative. That's 0. Okay, how about this problem? This was average rate of change, so upon taking a limit, we are going to get instantaneous rate of change, slope of tangent line, but we have a cusp point, and x is going to 3 minus. So if it is going to just 3, we won't have anything because this is a cusp point, but 3 minus, that means you're looking at on the left hand side. Forget about this right hand side and go left hand side, this only. And what's that slope? Slope of this line segment, again, this is negative 4/3. I could have written this problem like this, or through Newton quotient like that. Either way, the answer is slope of that line segment, negative 4/3. Now how about the right hand side? This is Newton quotient, but 0 plus, so this is slope for the right hand side. It's horizontal, so that's got to be 0. From this picture here, 0, that's not difficult to see. Harder part is to recognize what this is. Newton quotient to the right, or average rate of change with the right hand side limit. So this is tangent line to the right hand side, so that's slope is 0. The right hand side slope. Okay, so we are using this one or that one based upon the need. Okay, how about the next set of problems? Okay, repetition is good. We have a new graph. Also, I'm asking some limit problems as well. Okay, let's do some limit problems. What is the value of limit? Limit as x is going to negative 1 from the left hand side, minus side. X equals to negative 1 is right here from the left hand side, minus side. We have this curve, and that's going down, 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 all the way down to negative infinity. We have vertical asymptotes, so it should be like this, negative infinity. So limit is negative infinity or positive infinity. That has to be vertical asymptote. How about the right hand side? This is not vertical asymptote. It stops at y value equal to something. This doesn't go up all the way to positive infinity. It stops here at this y coordinate value. That's y coordinate is 2. So at x equals to negative 1, we have two fundamental different behavior. Asymptotic, and this is not asymptotic. So this one goes to negative infinity. This one stays at a certain real number. So we have these two fundamentally different answers here. This and that. How about x equals to 1 here? X equals 1 here, coming from the left hand side, coming from the right hand side. From the left hand side, what do you get? Y coordinate is negative 1, easy to see. And from the right hand side, y coordinate stops at 3. only this one is going down to negative infinity because only this one is asymptotic. Okay, let's go to the next set of problems. Let's copy and paste, and let's open up these. Limit as x going to negative infinity versus limit as x is going to positive infinity. Okay, negative infinity to the left this way, positive infinity going this way. Which one has asymptote? Do we have horizontal asymptote here? Clearly, yeah. So y-coordinate is getting closer and closer and closer to this horizontal asymptote, y equals to 2. So that is the limit at infinity to the left hand side. How about to the right hand side? We don't have horizontal asymptote. This is going up and up and up all the way to the positive infinity. So we are looking at two fundamentally different behavior. Horizontal asymptote and no asymptote is going up and up and up. Next, slope problems. And we have a bunch of Newton quotient. And you can see the slope here. The big deal is to locate the slope. This Newton quotient is for x equals to 2. So right here, what's the slope? This line segment has slope -2. You can clearly see it. You can write it as Newton quotient or the average rate of change along with the limit. Either way, you're looking at the slope of tangent line. How about the next limit? H is going to 0 minus at x equals to 1. Okay, 1 right here and 0 minus. 0 minus. So you're looking at only one-sided. Minus is negative side, so left-hand side slope only. What's this slope? Not the right-hand side, not the right-hand side. Forget about the right-hand side. This is 0 minus. So the left-hand side, this line segment has slope -3/2. You could have written as, I could have written the problem as Newton quotient or this way. Either way, you're looking at the left-hand side slope. Now we have two identical Newton quotients, and this one is 0 minus and this one goes to 0 plus. So left hand side, right hand side slope. At x equals 3 right here, and left hand side slope is this line segment. Right hand side slope is, okay, this is curved segment, so we need tangent line, but luckily this is horizontal tangent. So you're looking at this line segment and that slope, and 0 because horizontal line has slope 0. We are looking at -2 for the left hand side. Yes, the slope here has slope -2. And then 0 for the right hand side. Horizontal line is the tangent to the right hand side. Okay, so much for derivatives with graphs. And from next video on, let's do some formula problems.